Hi. Um, admittedly, I'm not entirely sure how to do this ratio of products using a closed model thing and what exactly you're doing or anything like that, but so a lot of the explanation I can't really help, but I can tell you this. I can know how to follow all this on my calculator, at least how to get the answer. So based on the view and example, so they gave you your matrix here. He's 3 by 3. And it tells you what you have to do is this, set this equal to 0. So this is ultimately a system of equations. That minus that x1 minus 0.5 x2 minus 0.3 x3 equals 0. Negative 0.3 x1 plus 0.6 x2 minus 0.1 x3 equals 0. So what you got to do is you got to put this in your calculator as a 3 by 4 matrix. So I'm going to go to matrix. All right, let's say he's a 3 by 4. So I'm going to put 0.8. Negative 0.5. Negative 0.3. 0. Negative 0.3. 0.6. Negative 0.1. 0. This last column is 0, by the way. Your last column is going to be whatever is here. So this is your first 3 by 3 right in here, and I have the last column right there. It's just a row of zeros. So I'm going to have negative 0.5, negative 0.1, 0.4, and 0. So all zeros on the last column here, and then you see negative. You see your matrix right there, and right there, and on the other one. Okay. Now, this thing right here is, I guess, is the part I can help you. It says, use technology to solve this system with x3 as a parameter. So that's the thing I was telling you about. You're going to get a row of zeros along the bottom. It's going to be your infinitely many solutions. So to explain the infinitely many solutions, we set the free variable being the last one, which in this case is x sub 3. So what do? I go to matrix. Math, reduced row echelon form. This is how you get those solutions, remember? We were talking about this the other day. Of matrix A. And yeah, see, I get this row of zeros in the bottom. I don't like these fractions. Let me just go math and turn them into a fraction. Cool. So, right, so you see this row of zeros? That means I know I'm going to have to go back to this equation world. Let me type here. Open up. Okay, cool. This is something else. Let's just scroll down to the very bottom. Okay, so from here, that's x1, x2, x3, answer. So what I got on my first row here is 1x1, or just x sub 1. No x sub 2's. Minus 23 over 33 x sub 3 equals 0. My second row has no x1 but an x sub 2 minus 17 over 33 x sub 3 equals 0 still. And your last one, right, you have the row of zeros, that was your free variable, so I just say x sub 3 equals x sub 3. All right, so then we solve for x sub 3 on all of them, right? So from this guy right there, I guess you're going to add it to both sides, and I'm going to be able to say that x sub 1 equals 22 over 23 x sub 3. See, it works this way because it's 0, right? 0 plus it, plus 22 over 33 x sub 3. If it's not, if it was like equals 2, it would be 2 plus 22 over 33 x sub 3. And then this one is going to be x sub 2 equals 17 over 33 x sub 3. Then I suppose what you do is you pick this common denominator so we have all integers, right? Because I can see from here that if x sub 3 equals 33, right, then x sub 1 would be 22 over 33 times 33, which would be 22. And x sub 2 would be 17 over 33 times 33, which is just 17. And I think that is the answer they're actually looking for, 22 colon 17 colon 33. Yep. So anyway, like I said, I'm not actually sure what exactly we're doing here, or what exactly a closed model is, or why we're doing it anymore, but I don't know. But I can say this, when it says find the ratio of products using a closed form, this is what you do. You do the I minus A, you can get your A right to get your new thing, then I tack on a column of zeros, put it in reduced row echelon form, and I get this thing. Then I can take this information and go back to equation world. Gets me here. I can solve for x1, x2, every variable. Then just pick your x3 so you don't have fractions. So it's going to be, 22 for x1, 17 for 2, and 33 for x3. All right. Okay, that's the best I can do. So I'm a little late on this. Somehow I turned off notifications on my phone. I didn't get it until this morning. But anyway, I'll see you around.